Hi everyone, my name is Maarten Sap, and today I'll be talking about my research, which is about reasoning about social dynamics and social bias in language. And what I mean by reasoning about social dynamics is essentially this ability that we have as humans to mind read while navigating everyday situations in our lives. And for example, when we see something like Tracy accidentally pressing against Austin in a small elevator and it's awkward, we can reason about why Tracy might have done this, and given two options like flirt with Austin or squeeze into the elevator, we can reason about the fact that it's more likely that Tracy wanted to squeeze into the elevator. And the way that we do this reasoning about situations and about people is by creating mental models or mental simulations that are influenced by common sense and world knowledge, as well as our own experiences. And this allows us to reason about the causes and effects of everyday situations or interpersonal situations, which is sometimes called theory of mind, but also reason about biases and power dynamics between social and demographic groups. And a lot of my research argues that models need to do this kind of reasoning about social dynamics because any data that comes from humans is inherently going to be influenced by social dynamics. And if AI systems are going to be trained on our data or interact with us, they need to account for that. And if systems fail to understand these dynamics, they can lead to really unfortunate or useless outputs, like, for example, recommending a second cooking range after buying a first cooking range. Usually people don't collect cooking ranges, or really harmful or catastrophic results, like when Microsoft released a chatbot that turned racist in less than a day. And this starts with understanding the dynamics that are present in text, for example, in NLP tasks like text classification, question answering, or text generation. Unfortunately, social common sense reasoning is still a challenge for machines. And the reason why that is because most current NLP systems are trained to maximize correlational patterns, or they're essentially doing curve fitting, as Udia Pearl put it. They're not trained to make inferences. Additionally, they're very limited to the knowledge that is contained in the training data only, and so that causes them to struggle to generalize to new domains, but that also makes them more likely to fall prey to spurious correlations in data, for example, biases in data. Finally, the knowledge that is reported in these text corpora that most NLP systems are trained on is not necessarily the same as common sense knowledge, because common sense knowledge is oftentimes not written down because it's more obvious to people. So my long-term goal is to make NLP systems human-centric, socially aware, and equity-driven. And this requires creating new symbolic formalisms to distill this knowledge, new interfaces between symbolic and neural knowledge, and new evaluations for analyzing the knowledges and biases that models might have learned. And during my research, I've taken several steps towards this goal in each of these three directions, ranging from social and interpersonal common sense reasoning to reasoning about social biases and toxicity. But today I will be focusing specifically on three projects only, starting with Atomic, which Atomic is a huge social common sense knowledge graph that contains 880,000 knowledge triples for AI systems to reason about the causes and effects of everyday situations. And what I mean by that is, given an event like X repels Y's attack, we can make all sorts of inferences about the implications of the event, like how people feel afterwards or what their intent was. And Atomic distills this knowledge in 9 different inference dimensions that cover the causes of the event, for example, that X might have wanted to protect others before repelling Y's attack, and also the effects of the event, for example, that X might want to leave the scene or feel angry afterwards, or that Y might get hurt or feel weak. And so one challenge with creating this knowledge graph is that in order for it to be useful, it needs to be high coverage and large scale. But how do you get that? One way to try is to extract knowledge from text. However, if you do that for common sense knowledge, you might find things like murdering is 4 times more common than exhaling. And this is due to the fact that text is subject to reporting bias, and noteworthy events are going to be inherently mentioned more than more common events. And specifically with common sense, it's not often written down because it's so obvious to people. And so instead, what we're going to do is we're going to elicit it from people through a new crowdsourcing framework that we designed, where we collect short natural language annotations around event prompts, which makes it more scalable than complex annotation schemes that people have used in the past for creating these common sense knowledge bases. And crucially, the natural language is how humans talk and think. And so when we ask about whether machines can be taught to make these atomic style inferences on previously unseen events, we can do that by combining the symbolic knowledge from Atomic, which is in natural language, with the language models that are pre-trained on large amounts of natural language. And this combination is what we call Comet, where we create a common sense reasoning engine with pre-trained language models. And simply put, how Comet works is we took a pre-trained transformer-based language model, specifically OpenAI's GPT, which was pre-trained on a large corpus of books, and we taught it to generate the targeted inference given an event and a relation from atomic. To show you how that works and that it works, we can give it a new event like Maarten gives a talk about his research and ask it why I did it. So here, the model thinks that I wanted to share knowledge, be informative, and be heard. And that's why I gave a talk about my research. And that before I could give a talk about my research, I needed to do some research and be a scientist and also be a professor. So part of the reason why Comet works so well is that it's due to pre-training, which seems to give the model some knowledge that it can use to make these inferences better, as evidenced by this ablation. But this raises the question of what else did Comet learn during pre-training? So for example, we can compare two events like the boss yelled at her male assistant and the boss yelled at her female assistant, and we can ask it what the reaction of the assistant is. And we see that in the case of the male assistant will want to apologize, leave, or leave the office, but the female assistant, the topmost likely reaction is to cry. And so it seems like Comet is learning general, specifically that women cry more than men. And this seems to be happening because Comet is acquiring social biases during pre-training on large corpora of text. And I should note that atomic contains generalist placeholders, so it's not coming from there. And we know that language will reflect existing social inequality inherently. So this raises the question, can we use NLP to reroute how people are described in text and maybe specifically how minorities are described in text? And that's what we did in our work Power Transformer, where we introduced a new task of controllable debiasing, where we ask, can machines learn to revise text to debias the portrayals of people? And specifically, the goal of controllable debiasing is to take a story sentence like May daydreams of being a doctor that portrays its character with in a very passive way with very low levels of agency, and rewrite it maybe in a collaborative setting to something like May pursues her dream to be a doctor, where May is all of a sudden much more decisive and has much higher agency. And as you guessed it, here we're looking at bias in portrayals through the lens of connotation frames of power and agency, which is a formalism that we introduced in 2017. And there are two main challenges to doing this task. The first challenge is that we have to go beyond paraphrasing because oftentimes the biases are baked into the actions character take, not just their framing. And on the other hand, we want to make minimal meaning changes to avoid going completely off topic where the meaning is completely different. So we want to make targeted edits with minimal meaning changes. The second challenge is that this is an unsupervised task. And so machine translation style approaches won't really work because there's no parallel data. Additionally, models that combine generators and discriminators, kind of like GANs, are also not going to work because they usually lead to disfluent output. And so instead, we're going to use a mask and reconstruct approach. And because that wasn't enough, we're going to also add a paraphrasing objective at training time and a vocabulary boosting mechanism at inference time. And so specifically how our model works is that we start with this input sentence and a desired agency level, and we're going to mask the agency markers from the input sentence and convert the agency level to a special token. Then we're going to pass it through a transformer-based conditional language model, here initialized with OpenAI's GPT. And then we're going to train on our joint objective, which has two parts. And first, an in-domain reconstruction objective, which takes the sentence from the rock story corpus, masks agency markers, and then optimizes the log likelihood of the reconstructed sentence. And then an out-of-domain paraphrasing objective, which uses pairs of paraphrases from a TV subtitles corpus and optimizes the likelihood of a sentence giving its masked paraphrase. And then at decoding time, we're going to use our vocab boosting mechanism, which essentially increases the likelihood of tokens that connote the desired levels of agency. So if we're looking at an example, if we want to rephrase the sentence, Weishi paused on the trail to something with more positive agency, we can see that Power Transformer successfully rewrites this to Weishi walked on the trail heading down, whereas ablated baselines where parts of the model have not been included fail to reach the desired levels of agency. And this shows that not only does Power Transformer work, but also can make edits that go beyond simple paraphrasing. And as a reality check, we can also confirm through automatic evaluations and through human evaluations that our model benefits both from all the components in the model, but also outperforms existing baselines in human evaluations. So at this point, I just want to make a quick intermediate summary of what I've talked about so far. So I've shown that models can be taught to make inferences about interpersonal social dynamics through Comet and Atomic. And I've also shown that models can revise and debias language, at least through the lens of the connotation frames of power and agency. And this raises the question of, could models mitigate a broader set of social biases? The answer is yes, but it might require designing a new formalism. And so that's what we did in social bias frames. And before I move on, I just want to quickly warn people that the rest of this presentation may be a little bit upsetting or offensive. So social bias frames is a new structured formalism that distills knowledge about harmful and biased implications of language. For example, if we have a statement like, we shouldn't lower our standards just to hire more women, the aim of this work is to flag that it's a problematic statement because it implies that women are less qualified than men. And this is a more holistic way of looking at social biases and toxicity, because binary offensiveness detection, which is how it's been done before, is very subjective and can actually backfire against the very minorities that it's meant to protect. Additionally, it's a much more trustworthy approach to this because social bias frames can actually provide explanations of the implied biases in text. And so the way a social bias frame looks is, given a post like, we shouldn't lower our standards just to hire more women, we're going to ask, is this offensive? Here, yes. Is it intended to be offensive? Maybe. Is it lewd or sexual? Here, no. If it's offensive, does it target a group or only an individual? Here it's a group, and that group is women, and it implies about women that women are less qualified than men. And then finally, we're going to end in a variable asking whether this is a in-group language or women here talking about other women, and this doesn't seem to be the case. So in the paper, we also introduced the social bias inference corpus, which covers 150,000 high-quality annotations from social media posts and can be used to study online biases that reflect real-world discrimination. So this concludes the part about social bias frames, and I wanted to share some more positive thoughts on where we can go from here. So towards my long-term goal of socially aware NLP systems, I'm really excited about developing models that can reason about different levels of social dynamics, combining atomic, social bias frames, etc. This might require new person-centric architectures because inherently we're reasoning about people, and maybe requires developing or keep developing new ways of assessing the reasoning skills that models might have, as well as thinking about ways to incorporate this reasoning into downstream tasks such as rewriting or dialogue. And then more concretely, I'm very excited about understanding and mitigating social biases in pre-trained language models. For example, how do social biases and toxicity in pre-training data affect these language models, which requires characterizing what kind of toxicity is in this data, also analyzing how this toxicity gets acquired through training dynamics, and maybe also measuring the effectiveness of steering mechanisms to avoid biased or toxic generations. Thank you so much for listening.